So today we have David Adelani from Masakhane and the Spoken Language Systems group at Saarland University, and he will be speaking today on the topic of MasakhaNER, named entity recognition for African languages. Thanks for joining us today, David.
Thank you, Andrew, for inviting me, and a big thank you also to people from Lancaster that are also part of this project, and also part of the Masakhane community. I'm David Adelani from Saarland University, and also active member of Masakhane. This project was in collaboration with many researchers, language experts, native speakers especially, and of about 10 African languages. So the idea of this project is to create a very first large name entity recognition data set for 10 African languages. And we hope to expand it to other African languages. So thanks for Paul, I think, Chiamaka, and also Ignatius, that are also part of this group. So the major motivation of our work is to increase the participation of Africans in natural language processing. And this is because when you consider the amount of publications, for example, that comes from Africa, there's the picture you can see here is in the year 2018. You can already see that there are very few papers coming from Africa, which shows that there's a lot of there's less NLP work coming from the African continent, and we have a lot of African languages, and there's need to really work on these languages. And the second thing is that we need to encourage benchmarking of natural language processing models on African languages. And if you think about it, it's because number one, 30% of the world languages are from the African continent. And less research is coming from Africa. And when you consider these languages, and you consider the average number of speakers, you find out that there are actually a lot of speakers. Most of the time, there are over 30,000 on average across the African continent. So the average number of speakers is only next to the European languages. So that means it's an important set of languages that we need to really pay attention to. So our major contributions are the following: to create a humanly labeled publicly available data set for 10 African languages, and we hope to expand this to other African languages. And we focus on making them publicly available because there are so many data sets that are available, but they have been annotated, but are not publicly available. And also we have some automatically annotated name entity recognition data set. But of course, there are a lot of quality issues with this automatically annotated data set. And another thing is that we focus on local news websites because we want to really capture important information from these communities where these languages are spoken. And using news article give us an idea of what kind of names are in these communities and what kind of locations are in these communities. And this is a better approach than just translating, let's say, English news into an African language. And we train multiple popular NER models, for example, by LSTM, CRF model, and also transformer-based models like BET and Excellent Beta. We explore different techniques like gazetteers and transfer learning to improve performance, because there are some of the data sets we have collected that have fewer entities, and we could augment this by information we get from maybe list of entities from Wikipedia or from phone books or geonames, for example. And we also make this work publicly available. We provide the code, the data, and the model. So name entity recognition is a core NLP task in information extraction. This involves identifying entities like personal names, location, organization, or date. Of course, we can have more fine-grained entities. For example, we could split location into GPE, which is geographical units, and we could also split it by cities, by states, by countries, having fine-grained entities. But in this work, we only focus on the coarse-grained, like personal names, location, organization, and date. And there are many applications of this, for example, in search engines, in question and answering system, information extraction systems, and also it plays a big role in the localization of voice and dialogue systems. So, like I said previously, we have some previously annotated NER datasets in African languages. The most popular one is the WikiNN, but it is automatically annotated. So they use the Wikipedia links from English to other languages to automatically annotate this dataset. And of course, there are errors because this was generated automatically. And the second issue with this dataset is that they're very small for most of the African languages. Most of the time, you only have less than 10,000 tokens. And you cannot really train a very efficient, a very good NER system with this kind of data because it's too small. Another data set that is commonly available is the SADILA, where they have provided name entity recognition data set for 10 South African languages. I think including the Africans. But this is based on government data, and there are also some quality issues with this data set. Another data set that people started working on a few years ago is the Loreri data set. But the problem with this data set is that it's not publicly available. And this is not very good for African researchers that want to work on it, because apart from they are collecting African data set, it's not also available for them, and they're also expensive. Compared to European universities where there's partnership, for example, with the Penn State LDC, there is no such partnership between many African universities and this organization. So they don't have access to this organization. So other small corpora are the Hausa by Heritage last year, and also Yoruba dataset, but these are very small corpus, like less than 2,000 sentences. So we focus on languages that are widely spoken across Africa, and also this is based on the availability of news corpora and also annotators for this language. For some languages, we only have 2 annotators. For some, we have 5 annotators. And for some, we only have 1. So it's very difficult to verify the quality of the annotation of one person. So if you consider, for example, Amharic, Kinyarwanda, Luganda, Luo, and Swahili, they are spoken in the East African part of Africa. And Swahili is also spoken in the Central Africa, in the Democratic Republic of Congo. While Wolof, Nigerian Pidgin, Hausa, Igbo, and Yoruba are spoken in the western part of Africa. And many of these languages are actually in the Niger-Congo family, which is the biggest family group in Africa. But we also have languages in the Afro-Asiatic, like Hausa and Amharic, and also we have Nilo-Saharan. So we have around 5 language groups. So it really covers a lot of family groups that we have in Africa. And also, these languages are spoken by a lot of people. Like Swahili is spoken in more than 8 to 10 countries, and Hausa is also spoken like in more than 5 or 6 countries in the West Africa and Central Africa. So these are really big languages, and they are spoken by a lot of people. Yeah. So there are a few language characteristics that we need to pay attention to. So we are working in the low research scenarios. We also need to have an idea of these languages, their properties, and what can make what can be the challenges of building name-entity recognition models for these languages. For example, if you consider the Amharic, it's in a different script, and that means it's difficult for you to transfer from English. For example, if you build an NER model for English and transfer it to Amharic, this is difficult, except you try to put the Amharic in another form similar to the Latin alphabet. So Amharic is using the feeder script, while most other languages are using the Latin script. Apart from the script, we find out that many of these languages, they are written, they kind of translate, or they have different forms of writing the same word. For example, Nigeria is written in at least 5 different forms. And also we have some diacritics on top, for example, Yoruba and Igbo. And another thing you can observe is that Kano also has some diacritics, but some words actually take the same form throughout the text. For example, Zang takes the same form. So these languages might benefit from things like transfer learning. You build your model in the language and you can transfer to another language. And these interesting properties can help us build better models. Another interesting thing is that you find 18 years here, and 18 years has the same form in many of the languages, but for some languages it's completely written out, like Igbo and Yoruba, everything, you don't have the keyword, you don't have the number 18 there. And how would you transfer from English to Yoruba, for example, with this kind of problem? Yeah. So for the annotation, we focus on 4 entity types: personal names, organization, location, and date. And the reason is that most standard benchmark dataset, they also use personal name, organization, location, and the last one is miscellaneous. But miscellaneous is very ambiguous, and from previous work that we have done, for example, for the Yoruba name-entity recognition, we have replaced miscellaneous with a date tag. And for the annotation, we use a tool called ELISA. It's an academic project by the UIUC lab headed by Heng Chi, and they have provided this tool for Masakhane for this project. The advantage of this tool is that it provides like an entity level interagreement score. So while annotating, you can already see how good your what is the agreement with another annotator. For this, we have multiple annotators, minimum annotator of 2 per sentence. And of course, because this, for most of the languages, is based on completely voluntary, and they're native speakers. Of course, they're native speakers, but it's voluntary. It took a lot of time to do the annotation, and it took around 6 months. And towards the African NLP workshop, a lot of people are really encouraged to do this annotation for their languages. So when you consider the interagreement annotation score, you can see that it's very high. the entity level F1 score is around between 96% and 100%. This is very high because for some languages that have two annotators, they were given specific instruction to resolve all disagreement. But for some more languages where they have more annotators like Igbo, they have the flexibility of of disagreeing a bit. Maybe one annotator thinks that this should be a date, another one thinks that, okay, this should not be a date. And we can still have some disagreement. And when you consider, for example, the flex kappa score, you see that it's very high. And even for many annotations, for example, like Igbo, they have very high kappa score. And for other languages, they have at least, if you consider the entity flex kappa score, they have at least 0.96. This is very high. For the languages that have 1.0 is just because they were just two annotators per sentence. They were given this instruction to resolve all the disagreement. So this is the final NAR data set. We have for 10 languages, and the source of the text that we annotated is also displayed. All the texts are coming from news sources. Amharic is from DW and BBC. Igbo and I think Nigerian Pidgin are also from the BBC Pidgin. Recently, BBC started expanding to many African languages, and their data or their text has been very useful for many natural language processing tasks. Okay, so and when you consider the size of the data set, of course, it's not up to like the standard data set of CONNEL 2003, but it's actually good enough to try a lot of our ideas. Most of the data set has at least between 2,000 and 3,500 sentences. Luo has the smallest number of sentences, like less than 1,000. And Wolof, although it's large, we found that when you consider the percentage of entities in this data set, they are actually very small. So we want to check how we can benefit from transfer learning for a language like Luo that has less number of sentences. If we are trained on many African languages, can we benefit from that to improve the name-based recognition performance of Luo? And also Wolof, because Wolof has very few number of entities. Although it's larger, the fewer number of entities also is a disadvantage because we cannot learn a lot from machine learning approaches. For our baseline model, we use the popular CNN by LSTM series model. This is the best model before the transformer models. And the second approach is the other two approaches are based on the transformer models. For the CNN by LSTM CRF model, the idea is to initialize this model with pre-trained word embeddings like glove, word to vec, or fast text. So for the other two approaches, the mean E, we initialize the model with transformer embeddings or the transformer model. For the mean E by LSTM, what we did was to extract sentence embedding from embed. Okay, multilingual BET is a model on its own, but you could extract contextualized embedding from it. So what people do is to use the embedding of the first token in the last layer, and this token is called the CLS. And when you fine-tune end-to-end, this is already very good enough. But if you want to extract embedding from the transformer model and you use the CLS model, we found out that actually gives poorer embedding quality. So what people do is to either average all the layers of the transformer. You just average all the values. So the transformer layer that we use at the base model, it has 12 layers. So you can average all the output embedding and use this instead of the CLS embedding. So this is the first approach we do, and it's actually similar to the way we initialize our by LSTM model by word embeddings. So the other approach uses transfer learning, where you already pre-trained the multilingual BERT or the SLM beta on many languages, and you now fine-tune on a task, like name entity recognition or text transformer. And we find that this approach actually gives better performance in the low resource scenario, even though the languages, even though the model were not pre-trained on these languages. So the first thing we check is the effect of out of vocabulary on the named entity recognition performance. So out of vocabulary is a big problem in NLP, especially if you do the traditional statistical approaches of natural language processing. But recently, there are many approaches to resolve this issue. For example, we use the byte type encode. We use the BPE. We use some word unit instead of word, and this allows us to capture more words that should be out of vocabulary. But still, we find that there's a correlation between the out of vocabulary of the entities in the test set compared to the performance of the NER model. The Hausa data set has like very low number of out of vocabulary, and because of this, we find better performance. Similarly for Swahili and Igbo, because the out of vocabulary is small, we could get better performance. And this is quite intuitive because they have learned a lot from the training set, and they have seen some of these entities, and they can generalize better at this set. However, for some languages like Amharic, we found that because of a very high out of vocabulary, this also results to much lower F1 score for the name entity recognition. Of course, there are a few issues that people have pointed out for Amharic. For example, there's a lot of misspelling, and this misspelling of the entities can also affect the performance. Okay. Then we also check the performance of the language model, the transformer language model. And when you look at the big transformer language model like BERT or SLM beta, we find out that they only work very well when you pre-train these languages. When these African languages have been pre-trained by this model. So, and many African languages are not actually part of the languages that these models have been pre-trained on. For example, the multilingual BERT supports around 104 languages, and in Africa we have at least over 2,000 languages, and the multilingual BERT only support 2 out of the 2,000 we have, Yoruba and Swahili. And for the XLM beta, it supports, and it was pre-trained on 100 languages, and it supports around, I think, 5 or 7 African languages. So what we find out that although these models are huge and they perform very well, if this language were not pre-trained on them, the kind of embedding you can extract from this model actually are not very good enough. What we observe is that a simpler model like CNN by LSTM CRF model may even perform better. However, when you fine-tune end-to-end, because they benefit from transfer learning, you can have better performance for all the languages they were not pre-trained on. And this is the case for Igbo, Kinyarwanda, Luganda, Lu, and Wolof. So I first present the name and serial recognition performance for the supported languages. So we compare the CNN by LSTM CRM model with the mean E SLMR by LSTM model. The mean E is the one we extract the sentence embedding from the transformer model and sending this information to the by LSTM model. Now what you can see here is that if these languages were already supported by this SLMR model, it performs better than the CNN by LSTM model. This is what most people report in paper. SLM Roberta is better. Yes, it's better for the supported languages. Like Amharic, Hausa, Nigerian Pidgin. Also, Nigerian Pidgin is very close to the English language. Of course, there are a lot of dialect there. But a lot of the important vocabulary and the entities are actually written in English. So we also find a very good performance for Nigerian Pidgin and Swahili. All these languages were supported. But if you consider the non-supported languages, what you can see immediately for the multilingual model, for the multilingual BET and the SLM Roberta, is that the CNN by LSTM model, which has less number of parameters, and sometimes like, let's say, like 2,000 or 5,000 parameters, compared to the MBET that has over 100 million parameters. And you can see that it's actually better than all this model if you extract the sentence embedding. Of course, if you fine-tune end-to-end, then through transfer learning, you can have better performance using the multilingual BET or SLMR. And this is what we can see, for example, Igbo, Kinyarwanda, Luganda, Lu, and Wolof. If you fine-tune MBET or SLM Roberta end-to-end, you have the best performance. Good. So after describing the strengths of the transfer learning, we also move to comparing multilingual BET and SLM Roberta. What you can see clearly is that SLM Roberta for many of the languages is actually better, especially if this language has been pre-trained on SLM Roberta. Hausa, Swahili, and Amharic are part of the SLM Roberta, so they have better performance. However, we find that the languages that are not supported by SLMR, in some cases, the multilingual BET actually gives better performance. And this is the case for Wolof and Igbo and I think Yoruba. But Yoruba is already part of the multilingual BET, but not SLM Roberta. So if the language is already pre-trained on this language, it gives better performance. Then we move towards improving over the baseline model. The baseline model we have described are the CNN by LSTM model, and also the multilingual BET and SLMR, fine-tuning them end-to-end. So one thing that we can use to improve, especially languages with fewer number of entities, is to use gazetteers as an additional feature. Gazetteers are just like a list of entities, maybe from Wikipedia or geonames or phone books that you have. You can just collect all these names of location or personal names and use them as an additional feature. Other approaches is transfer learning. We can have cross-domain adaptation, where you train on one domain and you try to adapt the model parameters to another new domain. So we move from Wikipedia domain and we want to transfer to the news domain. The second idea is cross-lingual adaptation, where we first train on a language, mostly high resource language, like English, and we want to see how it adapts to a low resource language, like Luo. So other ideas that we tried is aggregating all the label data set. The data sets are not so large when we compare to standard data set like Ontonodes 5.0 and Cornell 2003 data set. So combining all these data sets is actually still small compared to the standard English data set. And we want to see if these languages can learn from each other if you combine languages that are spoken in the same region, like East African languages and West African languages. But for this experiment, we only use the personal names, organization, and location. And the reason is that the date tag actually has not been annotated for some of the source domains that we would like to use, or the source languages that we would like to use. So the first approach is to use gazetteers. So gazetteers are a list of entities that we extract. In this paper, we extracted them from Wikipedia, and we use binary gazetteer features. The idea is very simple. If we have an entity from Wikipedia, it has a binary value of 1. If not, it has a binary value of 0. So we had this as an additional feature. So the way this model has been trained previously, if you ignore these gazetteer features here, is to have character representation and word embeddings concatenated together, and you send it to word level by LSTM model, and then you have the output, which is the output of the CRF model. So the only additional thing we had is the gazetteer features, and we concatenate these gazetteer features with character representation of word embeddings. And we have an autoencoder. So the autoencoder tries to reconstruct the gazetteer features. And this forces the word level by LSTM model to have a richer representation. And this approach was presented by Rich Wani and others. And we tried the approach for our setting. In their paper, they have experimented on at least one African language, Kinyarwanda, which gave very good performance. And we trying to exploit in this work. So from the gazetteer results, we find that that if the size of entities that we extract from the gazetteers are a lot for that particular language, many African languages has less number of text on Wikipedia, and also this limits the number of entities we can extract from Wikipedia. But for Nigerian Pidgin English, although we don't have a Nigerian Pidgin English Wikipedia, but we can still use the English Wikipedia because they are very close to each other. And Swahili, I think, has maybe the second largest Wikipedia in Africa, maybe after Malagasy. So what we find out that for these languages, we have very good increase in performance, sometimes even up to 5% increase. And for some other languages like Kinyarwanda, it was actually in the paper we used, in the approach we used, we already evaluated on Kinyarwanda, and we also find similar improvements with Kinyarwanda. But for languages that have fewer entities that we could extract from Wikipedia, the performance is almost the same, sometimes even slightly worse. For example, like Luo, Luganda, and Igbo stays the same. So the second approach is to do cross-domain transfer from Wikipedia or WikiNN dataset that's publicly available. But WikiNN is automatically annotated. Another disadvantage of this dataset is that it has very few number of tokens that we can train on, mostly less than 10,000 tokens. So the idea was to train on WikiNN and test on the same, and test on our data set. So the only difference is that is the domain different. The cross-lingual transfer is that we train on a source language, for example, English MasakhaNER, and we test on a different target language, like Yoruba or Igbo. For our experiment, we tried four languages. And the reason is that we wanted to try a high resource language and also languages that are somewhat higher resource in terms of African continent, and also try to check if the languages that are closer to where these low resource languages are being spoken, if it's better to transfer from there. So is it better to transfer from Swahili to Luo than to transfer from English to Luo? This is what we are trying to do experiment with. For example, in Rwanda, we find that if you do a cross-domain adaptation, you can see that the performance is very bad. Of course, it's better than zero because it's a zero-shot transfer. But if you transfer from English MasakhaNER data set, we can actually have like 30% improvement. And if we try Nigerian Pidgin English, which is closer, at least spoken in Africa, we even get better improvement. And if we try Swahili, that is geographically closer, we have even more improvement. By the way, Swahili and Rwanda are in the same language group. But surprisingly, Hausa that is not in the same language group actually give better cross-lingual transfer. And we observe the same thing also for Yoruba. So using a source language that is closer, that is geographically closer to the low resource language, at least for the name entity recognition task, it helps a lot. Because there could be some shared vocabulary, maybe a popular politician is being named across these different regions. So when we did some further analysis of the cross-lingual zero-shot analysis, what we find out is that the closer the language is to the low resource language, the better is the transfer. And this performance is an average over Igbo, Rwanda, Luganda, Luo, Wolof, and Yoruba. And when we pay attention to what kind of entities that we benefit more from, we find out that organization actually benefit more from transferring from Swahili and Hausa. Similarly, we find out that personal names also helps a lot if you transfer from a language that is very close to where this language has been spoken. So we ask a question: does pre-training another language help? For example, if you already trained your NER data set on Swahili and you want to transfer to Wolof, so basically you're pre-training twice. You take you first initialize your model with an NER model trained on Swahili dataset, then you further pre-train on Wolof. Do you get better improvement? This is the kind of question we ask. And the reason why we're doing this is, for example, for Wolof, is that it has less number of entities. And what we can find is that if you just train on English dataset and you continue training on Wolof dataset, you actually you do not do better than the baseline. But if you initialize your model with a Swahili model or Hausa model and do further pre-training on Wolof dataset, you can slightly improve the performance. But on average, actually, this trend is not very clear. But more obvious for Wolof is just because it has less number of entities. And pre-training on other languages actually gives it more opportunity to learn from other entities. So the last thing we tried is aggregating across different regions. So in the West African region, we combine Hausa, Igbo, Nigerian Pidgin, Wolof, and Yoruba dataset, and we trained on them and evaluated on this individual test set. What we find is that aggregating this training dataset kind of helps a bit for all these languages. In the East African language, we also find the same trend, especially for Rwanda, but the only exception is for Swahili. And the last thing we try is just to aggregate all the training dataset across all the 9 African languages that we have. And what we find out that also you always have some improvement in most of these languages, and except Swahili again. And but apart from that, we find that aggregating by region or across all these languages actually helps the transfer. In conclusion, we developed this annual data set for 10 African languages, and we evaluate multiple state-of-the-art models and establish some baselines. We also investigate how we can benefit from transfer learning and gazetteers to improve our names recognition model. In the future, we plan to expand to more African languages. On our list, we have Bambara, Chichewa, Ewe, Fon, Gumala, Xhosa, Zulu, More, Setswana, Shona, and Twi. So if you want to contribute, you should join Masakhane using this link. Thank you for your attention. The paper, the code, and the model are all available online. Thank you very much for your attention.
That's fantastic. What great talk, David. Thank you. I'm going to stop the recording here so we can have a more relaxed question answering session.
Okay, thank you.